Hey, this is Mr. Ayton. Welcome back to Pre-AP Chemistry. This is Unit 4, Covalent Molecules for Week 7. And what are we going to take a look at in Week 7? We're going to be taking a look at the VSEPR model. What is the geometric shape of molecules? If you remember, in Lewis structures, we were looking at how those atoms were bonded together. Were they bonded with single bonds, double bonds? Did they have unshared pairs of electrons? How were they covalently bonded together? But the VSEPR model shows us the geometric shape, the three-dimensional shape of a molecule. What does it look like? It's a model for us. It's the valence shell electron pair repulsion model. The valence shell electrons, they pair up. They pair up either in covalent bonds or they pair up in unshared pairs of electrons. And they repel each other because electrons repel electrons. Now, I like to take a look. I like to classify my shapes, my geometric shapes, my VSEPR, in bonding sites, electron domain bonding sites. So if you have one or two electron domain bonding sites, the shape will be called a linear shape. If we take a look at carbon dioxide, we know what the Lewis structure of carbon dioxide looks like. It looks kind of like this, where carbon, the central atom, is bonded to two atoms. It has two electron domain bonding sites. Something like fluorine gas is only going to have one electron domain bonding site because it's single bonded and there's only two atoms here. Whereas oxygen gas is going to also have one electron domain bonding site. Nitrogen gas is going to be triple bonded and have, again, one electron domain bonding sites. And so you can see these are all linear shapes. They are, you can see if you take a look at the bond angle, 180-degree bond angle because these bonds are going to repel and get as far away as possible. So if you have one or two electron domain bonding sites, you have what's called a linear molecule. If you have three electron domain bonding sites, something like BH3, BH3 is going to look like this. It's Lewis dot structure. And you can see these hydrogens are going to get as far away as possible, which means a bond angle of 120 degrees, 360 degrees divided by 3. And we call that a trigonal planar. It looks like a triangle on a plane because we have an atom bonded to an atom, bonded to another atom, bonded to another atom, and you can see it looks kind of like a triangle on a two-dimensional plane. So the linear and trigonal planar are both two-dimensional in their shape. But when you get the four bonding sites, we now become three-dimensional. Our molecule gets as far away as possible and becomes three-dimensional. So if we look at CH4, the Lewis structure looks like this, and you might think that the bond angle is 90 degrees, but it's not. Because remember, these electrons pair up and they repel each other, and they get as far away as possible. So the bond angle for this is 109.5 degrees. It moves three-dimensionally. So if you have four bonding sites, you can see four electron domains around this carbon with no unshared pairs, it's going to be what's called a tetrahedral shape. A tetrahedral shape. It kind of looks like where we have this atom is coming out, this atom is going back, and we have another atom further back, and we have a tetrahedral shape. Now, if we have something like NH3. NH3 ends bonded to three hydrogens, but there's an unshared pair, which is an electron domain. You can see there's four bonding sites. There's 1, 2, 3, 4 bonding sites, but there's one unshared pair, and this is called a trigonal planar shape. Trigonal planar shape. It's kind of like this atom comes this way, this atom comes this way, this atom comes kind of back. It looks kind of like a tripod almost. And the bond angle for this is going to be 107 degrees. This unshared pair repels a little bit more and pushes this bond angle to a smaller bond angle. And you can see four bonding sites, one unshared pair. Now water has still has four bonding sites, but it has two unshared pairs. You can see 1, 2, 3, 4 different from a linear shape. This will not be linear. It's actually going to push these atoms and make these atoms bent, what we call a bent structure. And our bond angle goes down to 105 degrees. So as we continue to gain unshared pairs, the bond angle gets less because there is more repulsion due to these unshared pairs of electrons. And so you can see that is our four bonding sites. You're going to really want to know your 1 to 2, 3, and 4 bonding sites for the shapes, the bond angles all of these different things. Make sure you know your linear shapes, your trigonal planar shapes, your tetrahedral, trigonal pyramidal, and bent structures, as well as bond angles. That's all we're really going to learn about in pre-AP chemistry, but I want to introduce you to more bonding sites, okay, and what these shapes are going to look like. Here we have 5 electron domain bonding sites, and you can see we have one atom bonded to 5 different things. This would be something like BRF1, 2, 3, 4, 5, BRF5, and see BRF5 is going to be what's called a trigonal bipyramidal. Trigonal bipyramidal. You can see there's a triangle here, a triangle pyramid, and then there's a triangle pyramid on the bottom. There's 2 triangle pyramids, so we call that trigonal bipyramidal. Something like this, which is SF4, you can see. Actually, this is going to be phosphorus, PF5. My bad there. This is going to be PF5, phosphorus pentafluoride. SF4 is where we have sulfur bonded to 4 fluorines, but there's an unshared pair. And you can see here, this is called a seesaw shape. A seesaw shape, yes, that technical name of seesaw, SF4. Here we have ClF3. You can see that chlorine is going to have 2 unshared pairs, and it's bonded to 3 fluorines. And you can see that is actually called a T-shaped molecule, a T-shaped molecule. And last but not least, we have XeF2, where we have xenon, yes, a noble gas bonded to 2 fluorines, and that looks linear as well. It's different than the linear with just 1 or 2 electron domain bonding sites, because there's actually 5 bonding sites. There's a bunch of unshared pairs on this, 1, 2, 3, 4, 5 electron domain bonding sites. So I just want to introduce you to 5 electron domain bonding sites: trigonal bipyramidal, seesaw, T-shaped, and linear. And last but not least, we have 6 electron domain bonding sites, where we have something like SF6, sulfur hexafluoride. You can see sulfur bonded to 6 fluorines, and we actually call that an octahedral shape. Octahedral shape, it kind of looks like a jack, where these all have 90-degree bond angles. You can see there's kind of like an Egyptian pyramid on the top, Egyptian pyramid on the bottom. Here we have an Egyptian pyramid on the top here, and without anything on the bottom because there's unshared pair. And that would be something like, let's see, BRF5. That's BRF5. And you can see there is an Egyptian pyramid on the top. There's a square. You can see the square plane on the bottom. And you can see it becomes a pyramid. And we call that square pyramidal. Square pyramidal, because it looks like a square pyramid. This guy here, this would be something like XeF4, and you can see it kind of looks like a square on a 2-dimensional plane. So we call that square planar. So these are shapes, again, you don't really have to know the 5 and 6 electron domain bonding sites. I just wanted to introduce you to them. Know that they are there. What you really want to know is the 1, 2, 3, and 4 electron domain bonding sites. And that is Unit 4 covalent molecules, week 7, and we'll be working on those in class. So see you later, pre-AP chemistry. Catch you on the flip side.